Picture your evening meal. Something roasted, something simmered, something that filled the room with smell before it ever touched your tongue. Now take that meal away. Take away every fire you've ever stood near. Take away every pot, every pan, every match. You are standing in a forest 2 million years ago, and dinner is a fistful of raw roots and a strip of muscle torn from a carcass the vultures haven't finished with yet. You will chew that meal for hours. You still won't get enough from it. Here is the strange part. The moment your ancestors first held food over flame is not just a footnote about better flavor. Some scientists argue it is the single event that made you capable of reading this sentence. Not because fire made food taste good, because fire began doing part of an animal's digestion outside its own body before a single tooth had touched it. That idea changes what a brain is, what a face is, what a day looked like, and who you sat next to at the end of it. This is the story of the meal that built a species. Imagine waking at dawn with no plan for breakfast, because there is no breakfast. There is only foraging, and foraging is the entire job. You spend your morning pulling tubers from packed earth with a sharpened stick. You spend your afternoon cracking nuts that fight back. You spend hours chewing, actual, continuous hours, because raw plant tissue is wrapped in cellulose walls your gut cannot break down on its own. Chimpanzees, our nearest living relative, still live this life. Researchers who followed wild chimpanzees found they spend nearly half of their waking hours just chewing. Not hunting, not resting, not socializing, chewing. If humans still ate this way, you would need something close to 6 hours of jaw work every day just to stay alive. 6 hours. Before work, before childcare, before anything else a day requires. Now add the other cost. Raw meat is tough and sinewy. Raw plant food is often bound up with toxins the plant produces specifically to stop animals from eating it. Bitter alkaloids, resistant starches, fibers built to pass through a gut undigested. Your ancestors were, in a very real sense, in a negotiation with their own dinner, how much energy the food contained, against how much energy it cost just to extract that energy through hours of chewing and slow fermentation in an oversized gut. Your ancestors did not invent fire. Fire already existed. Lightning had been splitting trees and igniting dry grasslands for hundreds of millions of years before a single hominin walked upright. What changed was not fire's existence. What changed was attention. At sites like Wonderwork Cave in South Africa, archaeologists have found burned bone and ash dated to roughly 1 million years ago, sealed deep inside a cave where a wildfire could not have reached on its own. Something or someone carried a burning branch inside. Picture that moment honestly, not a triumphant discovery, but a frightened group watching a wall of orange light devour the grassland they'd walked through that morning. Fire to nearly every animal on the savannah meant flee. But in the ashes left behind was something else, the scorched carcasses of animals too slow to escape. And those carcasses smelled different. Fat rendered. Meat already loosening from bone. That is likely how it began, not invention, but scavenging. Long before anyone could start a fire, someone learned to keep one alive, carrying an ember home, feeding it twigs, shielding it from rain. Keeping a fire burning for months or years without matches is its own skill, one demanding memory and cooperation. Someone had to tend it while others foraged, possibly one of the earliest forms of teamwork our lineage depended on. Wonderwork Cave is not the only clue. At a site called Jesher Benot Yaakov, on the banks of an ancient lake in what is now northern Israel, archaeologists found something even more telling than a single burned layer. They found the same small patches of burned material appearing again and again, at roughly the same spots, across many layers of sediment spanning thousands of years. That repetition matters. A single lightning fire leaves ash scattered wherever the flames happen to spread. A camp that returns to the same hearth, layer after layer, for generation after generation, is doing something a wildfire never does. It is choosing where to build. Dated to around 790,000 years ago, Jesher Benot Yaakov suggests that keeping fire wasn't a rare, lucky accident confined to one cave. It may have already become a habit, carried from camp to camp, passed down like any other skill worth remembering. At some point, nobody can say exactly when or by whom, a piece of meat sat too close to the coals, and someone ate it anyway. It must have been strange. The texture had changed. It came apart differently in the mouth, needing less grinding from molars already tired of raw food. This is the pivot point anthropologist Richard Wrangham has spent decades studying: the cooking hypothesis, the idea that controlled fire didn't just make meals more pleasant, but rewired the economics of being human. Cooking is not really about taste. It's about predigestion. Heat breaks protein bonds before your stomach has to. Heat ruptures starch granules, a process called gelatinization, turning stubborn raw starch into something your enzymes can access almost immediately. Fire had already done part of your gut's work before your teeth touched the food. In a 2011 study, researchers fed pythons meals of raw meat, cooked meat, and ground meat. The pythons eating cooked meat spent noticeably less energy digesting it than those eating it raw. Less work for the body meant more energy left for everything else. If cooked food takes less force to chew, a jaw built for crushing raw fiber all day becomes an unnecessary investment. Bone and muscle are metabolically expensive tissue. Selection doesn't keep expensive machinery running once its job gets easier. Across the fossil record of the genus Homo, the pattern shows up directly in stone, molars shrink, jaws shrink, and the heavy chewing muscles that once needed a bony ridge across the skull for anchoring gradually disappear. Smaller jaws freed up space. Facial architecture runs on a tight budget. Every millimeter the jaw doesn't need becomes a millimeter available for something else. Chewing wasn't the only expensive machine your ancestors carried. Digesting raw plant fiber requires a long, complex gut, especially a large colon for slow fermentation. Gorillas, eating enormous quantities of raw fibrous plants, carry guts built for exactly that. The modern human gut, by contrast, is notably smaller relative to body size than you'd expect for a primate our size. This sits at the center of what researchers Leslie Aiello and Peter Wheeler call the expensive tissue hypothesis. Brains and guts are both metabolically costly. A body typically can't afford to enlarge one without shrinking the other. Cooking, by pre-breaking down food before it reached the stomach, may have let the gut shrink without starving the body, freeing energy a growing brain badly needed. Your brain, right now, is spending roughly a fifth of your body's entire energy budget, while making up only about 2% of your body weight. No other organ is that hungry per gram of tissue. Brains this expensive don't evolve casually. They require a stable, concentrated calorie source delivered daily for years while the brain is still developing. Wrangham's argument is direct. Raw food, chewed for 6 hours a day and digested slowly, could never reliably fund a brain this large. Cooking changed the math. More digestible calories, extracted faster, funneled into neurons instead of a shrinking gut. The timeline lines up in a way many researchers find compelling. Homo erectus, appearing roughly 1.9 million years ago, shows the first major jump in brain size in the human lineage, alongside a smaller jaw and a body built for endurance rather than raw chewing power. You can see this body plan almost complete in a single skeleton. In northern Kenya, near Lake Turkana, researchers uncovered the nearly complete remains of a Homo erectus boy who died about 1.6 million years ago. His nickname is Turkana Boy, and his skeleton reads like a blueprint for a different way of living. long legs built for covering distance, a narrow rib cage and a slim waist, nothing like the wide, barrel-shaped torso a large raw food gut would require. It is the skeleton of a species that no longer needed to carry a fermentation vat everywhere it went. Whether cooking gets full credit for that change, or only part of it, Turkana Boy's proportions match a body that had already renegotiated its relationship with food. But this is not settled fact. It's one of the most debated ideas in human evolution. The strongest objection to the cooking hypothesis is timing. If cooking caused brain expansion around 1.9 million years ago, there should be clear evidence of controlled fire from that period. There isn't much. The earliest widely accepted evidence of habitual, controlled fire, hearths, repeated ash layers, burn patterns that rule out wildfire, doesn't clearly appear until roughly 300,000 to 400,000 years ago, over 1 million years after Homo erectus's brain had already begun expanding. That's a serious gap. Some researchers argue cooking came later, as a consequence of a bigger brain and cleverer tool use, not its cause. In their view, meat-eating and stone tool processing alone could explain much of the early growth, with cooking arriving afterward as a further boost. Wrangham's response is that fire evidence is fragile by nature. Ash and charcoal are among the most easily erased traces in the archaeological record. Absence of evidence in a record this old and incomplete isn't the same as evidence of absence. The debate gets even messier when you look at other famous fire sites. For decades, the cave of Zhaokudian in China, once home to Peking man, was held up as clear proof of fire use hundreds of thousands of years ago, complete with thick layers of what looked like ash and soot-blackened walls. Then, in the late 1990s, a team of researchers re-examined those layers with modern lab techniques. What looked like ash, under a microscope, often turned out to be naturally decayed organic sediment, with no clear sign it had ever burned at all. It was a humbling reversal. A site cited for a generation as textbook evidence had to be quietly downgraded to uncertain. It is a useful reminder that some of the most confident claims about ancient fire have not always survived a second, closer look. Neither side has definitive proof. What both agree on, at some point, cooking became part of daily hominin life, and its effects, once established, were profound. Whatever the exact timeline, once fire became a daily fixture, it reshaped more than digestion, it reshaped the day itself. For nearly every other primate, night is dangerous, and dangerous means still. Chimpanzees build nests and go quiet at dusk, hidden from predators that hunt in darkness. But firelight pushes back the predators that once ended the day for you. Some researchers, including comparative sleep studies of modern hunter-gatherer groups, suggest that groups with fire tend to sleep somewhat less than expected and stay socially active well after sunset, talking, not just resting. Imagine that shift. A portion of every single day, invisible to fossils, suddenly opens up. Hours that used to be spent frozen in the dark, waiting for sunrise, become hours spent sitting, talking, watching the flames, near other people. A cooking fire creates a problem no raw forager ever had to solve: timing. You cannot cook and eat instantly, the way you can pluck and chew a berry on the spot. Food has to be carried back. Someone has to build the fire. Someone has to wait. And waiting creates a natural moment for sharing, a meal, rather than a scattering of individuals each eating alone as they find food. This may be one of the quiet foundations of human pair bonding and cooperative family structure. If a fire and a cooked meal require defending, then a stable partnership and a hearth to return to becomes valuable in a way it never was for animals who simply ate wherever they stood. Sharing a fire also means sharing time in a fixed place, face to face, for an hour or more at a stretch, a rare thing for a foraging animal. Some language researchers have proposed that this daily, unhurried, firelit gathering may have provided exactly the kind of low-stakes social space where gesture, sound, and shared attention could slowly evolve toward something closer to language. This idea, like much of the story, remains a hypothesis, but a suggestive one. A cooked, energy-dense meal doesn't just benefit adults. It benefits the most fragile member of any group, a weaned child too young to chew tough raw food, but too old to nurse indefinitely. Softened, mashed, cooked food could be prepared specifically for a toddler's limited teeth and undeveloped jaw. That option barely exists in a raw food world, where an infant is largely restricted to milk until their jaw strength catches up to adult-level raw food. Shortening that dependency window has enormous consequences. Some researchers argue this shift may have helped shorten the natural spacing between human births compared to other great apes, one small piece of the story behind how human populations were able to grow at all. Fire changed the value of meat itself. A raw kill spoils, attracts rivals, and requires immediate consumption of parts the body can actually break down without much processing. Cooking transforms that calculation. Heat kills many of the parasites and pathogens riding along in raw meat, a serious, constant risk for any predator eating fresh kills in the open. Cooked meat, in a very real sense, is safer meat. It's also more efficient meat. Heat renders fat that would otherwise be difficult to access and loosens muscle fiber bound tightly by connective tissue. That single shift may have made hunting itself more worthwhile, encouraging Homo erectus, a species with clear anatomical adaptations for long-distance movement, to travel farther and rely more heavily on meat as a dependable part of the diet. A dependable, cookable food source may have also mattered for something bigger than any single hunt: migration. Homo erectus was the first hominin species known to leave Africa entirely, reaching as far as present-day Georgia, China, and Indonesia. A species that could carry fire and adapt to new environments with new plants and animals had a survival toolkit no earlier hominin possessed. Fire didn't just cook dinner. At Pinnacle Point, on the southern coast of South Africa, archaeologists found something that looked, at first, like an ordinary stone tool. Under closer study, the stone had been carefully heated in a buried fire pit, then cooled, then flaked into shape, a process known as heat treatment. Heating certain stone changes its internal structure, making it easier to strike into sharp, precise blades. That kind of tool-making has nothing to do with a single lucky bite of roasted meat. It requires knowing how hot a fire needs to be, how long to leave the stone buried, and how to plan an entire tool-making process around a step that happens out of sight, underground, hours before the actual carving begins. Cooking food and cooking stone, it turns out, may have grown up side by side. You don't need a time machine to test some of this. In 2005, Wrangham and colleagues tracked how much energy animals spent digesting cooked versus raw meals of the same food, and found cooked food consistently required less metabolic effort to extract the same calories. The Python study wasn't the only test. In 2009, the biologist Rachel Carmody, working with Wrangham, ran a similar experiment on mice, feeding them identical meat or identical sweet potato, some raw, some cooked, some simply pounded into a paste. Cooking made the biggest difference of all. Mice on the cooked diet gained more weight than mice on the raw diet, eating the exact same food, even when the raw food was mechanically processed first. Heat was doing something grinding alone could not. Human trials point the same way. When researchers had volunteers eat identical meals of meat or starch, raw versus cooked, and measured what came out the other end, the raw meals consistently left more usable calories behind, undigested, unclaimed, and wasted. Human studies point the same direction. Researchers comparing modern strict raw food dieters found that those eating a very high proportion of raw food often struggled to maintain stable body weight, and in some studied groups showed disrupted fertility, a modern echo of the energy shortfall your ancestors would have faced every day without fire. None of this proves cooking single-handedly built the human brain. It proves something narrower, but still remarkable. Cooked food reliably delivers more usable energy for less bodily cost than the same food eaten raw. Whatever else is debated, that mechanism is real, measurable, and repeatable in a lab right now, not just in the deep past. Here is the strangest thought this story leaves behind. Your jaw is smaller than a chimpanzee's proportionally, not because you're weaker, but because you inherited a body that quietly assumes food will already be broken down before it reaches your mouth. Your gut is shorter than a gorilla's relative to body size for the same silent assumption. Your brain runs on a rich, steady stream of energy your ancestors could never have supplied on raw food alone. None of that is a metaphor. It is architecture. It is written into bone density, molar size, colon length, and the wiring of a brain that assumes an easy calorie is coming. This is why, when modern people attempt to eat entirely raw, they often struggle to get enough calories, despite having access to more food variety than any hunter-gatherer ever did. Your body isn't built for a world without fire anymore. It was re-engineered over 1 million years around the assumption that something would already be done to your food before you ate it. Tonight, somewhere, you will probably eat something warm. You won't think about why the meat is tender or why the potato falls apart under a fork instead of fighting your teeth for 5 minutes per bite. You won't think about the 6 hours you didn't have to spend chewing to earn those calories. You won't think about the campfire that made it possible for someone 1 million years ago to sit still after dark instead of hiding from it. But it's there anyway, underneath the plate, underneath the smell rising off the pan, underneath the ordinary, unremarkable fact that dinner tonight took 20 minutes instead of an entire afternoon of raw, grinding effort. Every kitchen is a descendant of that first fire someone was brave or desperate or simply curious enough to carry home. Every meal you don't have to fight for is a small, quiet inheritance from a species that learned to let the flame do some of the work first. The next time you sit down to eat, you might notice it differently. Not just a meal, 1 million years of the fire still burning quietly on your behalf long after it went out.
If you enjoyed this, make sure to subscribe and like our video to watch more research like this.